I have a rotational equilibrium problem, and it reads, a 750 kilogram transformer rests 0.9 meters from the left edge of a 3.5 meter long, 350 kilogram steel beam as pictured below. The beam is supported at both ends, L, left, and R, right. Calculate both support forces and check your answer. So as you see in the diagram, you have your transformer and your beam. Both have gravity being exerted, and so their forces are both down. And you have your right and your left supports having a force upwards on the beam, because without those two, the forces would be unbalanced and there'd be acceleration, so it'd fall. And so since the bridge isn't falling, when you set up your sum of forces equation, you have your transformer and then your beam, and those are being subtracted by both the right support and the left support, and that equals 0 since the bridge isn't moving the beam. And so to solve this, since you have two variables you don't know, you can set up a sum of torques equation. And since you have two variables, you can set up it so that it's from the left, so that the left torque is 0 because that is the quote-unquote center. And so from the center, you have a transformer, which its force is 750 times 9.8, and then that is 0.9 meters from the left side. And then you have your beam, which is 350 kilograms times G, and that center of mass is at 1.75 meters. And then finally, you have at 3.5 meters, you have the right support force, which we don't know, so we call it R. And that's being subtracted because it counteracts the two others. And so you set that equal to 0. And since you now only have one variable, you can algebra it so that you combine these, and then you divide by 3.5 and you get 3,605 newtons for the support force of the right side. And so now, since you have, looking back at our sum of forces equation, since you now have the force for the right side, you can substitute it in, and then you have all of them except for your force on the left. So then when you plug in values, you get 7,175 for the newtons of force for the left side. And so further checking this, you can set up your sum of forces equation. And so you have the transformer, the beam minus the two supports, and all that equates to 0, which shows that both forces are correct. Thank you.